Today we're going to be working with characteristics of relations and functions. So let's first look at the Cartesian coordinate plane. We're going to label our quadrants. So first you have quadrant 1, quadrant 2, 3, and 4. And where it has the spaces for the quadrant points, I want you to go ahead and label whether it should be positive or negative. In quadrant 1, we have our positive. In our quadrant 2, we have negative. And in quadrant 3, we have negative. And in quadrant 4, we have positive. Okay, so let's look at the right-hand side. It says on the graph provided, we're going to label each axis. So we also want to label our x's and our y's. We labeled each quadrant, and we indicated whether the coordinates would be positive or negative in each quadrant. Make sure you know what each quadrant is and also whether it's the x or the y axis. Okay, now let's look at number 2. We're going to go over a few vocabulary terms. What I'm going to do is go ahead and give you the verbal description as well as the representation on the coordinate plane. So we talked about this yesterday in class about the origin. Well, origin is going to be right here in the center of the graph. And that's what's going to be located 0, 0. And under the verbal description, I want you to write. For the first dot, it's going to say intersection of the x equals 0 and y equals 0. So I have the intersection of the x equals 0 and y equals 0. Next, I want you to write intersection of x and y axis is the intersection of x and y axis. And the last one is that it is the point 0, 0. So you should have 3 verbal descriptions under origin. Okay, the next one we're going to work with is ordered pair. Under ordered pair, I want you to label where the x and the y values would be. So if you see on the ordered pair, my x is what's going to go to my left and my right. It is horizontal, and my y is going to go vertical, which is up and down. Under the description, I want you to put that the point is x comma y, and that it is the representation of the x and the y coordinate. So you should have 2 definitions under the verbal description for ordered pair. So let's go to the next page. The next one we're looking at is relation. Under relation, I want you to go ahead and plot the points, what I have under the representation on the coordinate plane. And under the verbal description, I want you to write, it is the set of ordered pairs represented by a set of points, graph, or an equation. Okay, now let's look at domain. All right, under domain, you have a few points that you can plot, the first one being 1, -1. And under my definition, I'm going to write the set of all x coordinates in a relation. And remember that it is also the independent variable. So it is my independent. Okay, next we're going to look at the range. The range, I want you to plot the exact same points as you did in domain. So here I have 1, -1. I have 1, 2. And I have 3, -1. And under the definition, I want you to write it is the set of all the y coordinates in a relation, and it is the dependent variable. Dependent. Okay, so you should have under range, again, it's the set of all y coordinates, and it's the dependent variable. So let's look at function next. My function, remember, is a relation in which the domain is paired with exactly one range. The set of points in which x values only occur once. So remember, my x does not repeat. And then the last one is the graph where any vertical line will only cross the graph once. So let me give you an example. For instance, just like we worked with the other day, my absolute value parent function, that is a function. My x values do not repeat. Okay, so let's go ahead and turn to page 3. Okay, so the next two definitions are going to be discrete and continuous. So under discrete, you should see about 4 dots plotted. Okay, these are going to be your actual individual points. So if I list out the x and y coordinates, that is a discrete graph. Okay, the points are not connected. Remember what I told you earlier, don't just connect them because you want the dots connected. The next one is going to be continuous. A continuous graph is going to be a line or a smooth curve, and there's an infinite number of points. The easiest way to tell whether a graph is connected or not, if we look at the example for a continuous graph, I'm going to be looking for those arrows. Remember, that's what means that my graph is going to continue forever and ever. So then the next two definitions, we're talking about increasing and decreasing. Under increasing, I want you to write that both the x and the y values will increase, and my function will go up from left to right. For decreasing, my x values increase, but my y values will decrease. And here, when I read my graph from left to right, the function will go in a downward direction. Based on every definition that I have given you, you should be able to go ahead and answer questions 3, 4, 5, and 6. So I do want you to go ahead and try those problems, and we will answer any questions in class that you may have. You also will have a quiz tomorrow over quadratics. So make sure that you watch the videos A6-1 and A6-2 to review, as well as looking over these definitions. Good luck studying. See you tomorrow.